So since this ax1 equals to lambda x1, this lambda is -2. So you can see that this ax1 equals -2 lambda x1 alpha t e to the minus 2t. That first term and this term are the same, so you can cancel out. And you can also see the other term, this e to the -2t are the same, and they are now equals to 0, so we can cancel out. Then what we left in this equation will be alpha x1 minus 2z equals to a z plus 0, 10. Okay, so this is what we left. And then how to solve our function alpha and z, then what we can just move everything with the z part on the right, and then all the other part in the left. So it's alpha x1 minus 10, 0, 10 equals a plus 2I z. Okay. Then we know what is x, we know what is a, we know what is I. Then we can try to get what is alpha and z. Okay. So we can put our number into the equations. That az, which is a2, -2, 1, -1, z, that is equals to alpha, -2 alpha, -10. Okay, so just remind yourself that this a plus 2I is this matrices times z will be equals to this x1 will be 1, -2. So 1, -2 alpha minus 0, that will be -2 alpha minus 10. Okay. Then we are solving these equations. We can write this z as z1, z2. So 2, -2, 1, -1, z1, z2 equals to alpha, -2 alpha minus 10. And where you can get 2z1 plus z2 equals alpha, -2z1 minus z2 equals -2 alpha minus 10. And if you put this equation 1 plus the equation 2, you can get 0 equals to negative alpha minus 10. So you can get our alpha equals -10. Okay. Then put this alpha into the equation since they are linear dependent equations. So we can just try to solve one. 2z1 plus z2 equals -10. Okay. Then you can get the relationship between the z1 and the z2 and have infinite solutions. We will just have one solution represent here, but you can have many. Okay. So z2 equals to 0, z1 equals to -5. Okay. So after you have z, you have alpha. What you can have is u by p. So by p is alpha x1t plus z e to the -2t. And your alpha is -10t. Okay. -10t. X1 is 1, -2. Okay. Plus z is -5, 0. E to the -2t. In the end, your particular solution will look like -10t minus 5 times e to the -2t. The second solution is 20t e to the -2t. Okay, so that is u by p. Then you can construct your final general solution, which is y equals yh plus yp. That is equals to c1 e to the -2t plus c2 e to the -t minus 10t plus 5 e to the -2t. This is negative 2c1 e to the negative 2t minus c2 e to the negative t plus 20t e to the negative 2t. And this is constructed with the homogeneous part and the particular part. Then in order to find the unique solutions, you need to introduce your initial value problem, right? Going back to our main topic, initial value problem. We know y0, that is the initial value. So y1 0 and y2 0, that is equals to 0 and negative 5. And if you put 0 for the t, you can get also two equations here, which is c1 plus c2 minus 5. The second equation when t equals to 0 is negative 2c1 minus c2, and that is 0. So you can get two equations and you have two constants, which is c1 and c2. You can solve what is your c1 and c2, right? So your c1 is equals to 0, your c2 is equals to 5. That is your final solution with the constant already represented by the value, solving by the initial value problem. So your final unique solution will be equals to 5e to the negative 5, negative t, plus, minus 10t plus 5e to the negative 2t. Second row is negative 5e to the negative t plus 20t e to the negative 2t. Okay, so that is your final unique solutions after using the initial value problem. And you can see there is no arbitrary constant because you already solved them by the initial value problem.